So, what we've learned so far. We've learned that for simple interest, I is equal to PRT. So that's our interest. And in order to get the total amount of money that we've saved over time, that's equal to I plus P. Now, the next thing that we're going to do is we're going to make sure I basically took the time to make sure that we identified all of the terms that are used in these equations. So remember that your principal is your start amount. Just like what we were studying before in the previous unit. Very close. All right, and just remember that when we're talking about simple interest isn't a straight line. It has its own starting point, but then it's a straight line. For the compound interest, we have A is equal to P, 1 plus I to the n, and in order to find the interest, we have this equation. The interest is equal to not the principal minus the A. It should be the final amount minus the starting amount, which is our A value minus the P value. And just like before, we have all our terms described. And what I want you to do is I want you to remember that something like this looks like our original exponential functions that we studied a while back. So let's move on to today's lesson. Let's talk about some of these synonyms. So if you ever want to find out if something is a total, we sometimes talk about the future value. Or sometimes you hear the term amount. At end. Okay, that's it pretty much. As we go on, sometimes you hear another term called, remember P, we said that was the principal. We sometimes call that the present value. Now, remember the A value in our basic equation, A is equal to P 1 plus I to the n. We say A could be the amount at the end, or we would call this the future value. All right. Let's move on to the new concept that we were studying for today. It's called the present value formula. So the present value formula is going to be based on what you studied before, which was this beautiful equation that we have here. A is equal to P 1 plus I to the n. Now, this one is a forward-thinking type of calculation because if you think about it, this n value is positive. We could think of this n value as positive. This is a future calculation. Now, if we wanted to find something that was going back in time, you have to consider something. The A value has got to be bigger than the P value if it's growing over time, right? Now, because it's growing, we could write P is equal to A but we need to times it by something. And we're going to use our 1 plus I to the, instead of n, we're going to use negative n, because what it's going to do is it's going to take the final amount and bring it back down to our original amount. And that is what our new equation is for today. So let's go and take a look at an example problem. That shouldn't be too difficult. So example 1. Emanuela needs to know how much money she should put in the bank today so she'll have $5,500 in 4 years. She invests money at 6% per year compounded monthly. How much does she need to invest now? So because we need to know how much money we need to invest now using compound interest, that is identified by the fact that it says it's compounded monthly. We're going to have to use our equation. P is equal to A 1 plus I to the negative n. Now, let's go through all the variables. We got P, we've got A, we've got I, and we have n. It's such a pain, isn't it? Now, in order to do these calculations, we got to fill all the information out. So this part here is our A value, because this is what we want in the future. So we want our A to equal $5,500. Now, let's go and find out what our I value is. Our I value is 6% compounded monthly. So 6%, just move the decimal place over twice. That ends up being 0.06, and we're going to divide by, because it's monthly, we're dividing by 12. Now, as for n is going to equal, well, it's going to equal 4. But then we have to times it by the compounding number. In this case, it's 12, which is equal to 48. And now we just do our substitution directly in. And we end up with this. Now, you know you're in trouble if you're looking to get a smaller number and that exponent is not a negative. If it's not a negative, you know you've done the equation wrong. So remember, if you start with a bigger number, we're going to end up with a smaller number in the end. So in this case, we now have our final amount being $4,329.04. So our final statement is this. So therefore, Emanuela needs to invest $4,329.04 in order to make her money of $5,500 in 4 years. All right, now let's take a look at example 2. Now, example 2 is also talking about loans. So now I want you to do is I need to impress upon you what the concept of a creditor is. A creditor is somebody that literally says, I'll give you some money, but you're going to have to pay me something in order to borrow it, right? So maybe you give them, say, $1,000, and they promise that they're going to give you $500 in interest. So that means you're going to make a total of $1,500. And now a lot of banks work this way in order to make their money. Now imagine we have a new person in our life. His name is Jesus. Jesus at one point decides to take out a $3,000 loan that's due in 4 years. So the $3,000 is going to be due in 4 years, right? And basically the interest is 5%, 5.7% per year compounded annually. So if you think about it, the interest is already tacked on to the original amount. So he's owing $3,000 in 3 years. Now imagine if he was able to pay off the money today. So in order to figure out that, what we're going to do is we're going to start with our basic equation. When we want to pay off a loan, we have to use P equals A 1 plus I to the negative n. And then we have to work through our pain to get our answers. Now, we know that the total amount of money that he borrowed is $3,000. So what we need to know is, if it's $3,000, we need to find what these other things are. Now, our percentage is 0.057, and we're going to write this in a slightly different way. So we're going to divide this by 2. And now n is going to be 8, is going to be 4 years. So we're going to take 4, and then we're going to multiply that by 2, and that will give us 8. So now let's substitute into our equation. So P is equal to, is this 3,000 bracket 1 plus 0.057 divided by 2, n bracket raised to the negative 8. And we get this as our final answer, $2,396. Now, let's see what our final statement is. So, therefore, the principal of the loan is $2,396. And we're done. Your homework is based on the sheets that I've provided. Good luck.